Have you ever wondered how Julius Caesar sent secret messages? Today, we'll explore this ancient technique known as the Caesar Cipher. The Caesar Cipher uses two simple mathematical formulas, one for encryption and one for decryption. Let me show you how we transform plaintext into ciphertext, using each component of the cipher. First, we start with the plaintext, the original message you want to encrypt. For example, let's use the plaintext, attack. Anyone who sees attack understands its meaning. To make it unreadable, we use the cipher. Next, we need a key, a number that determines how many letters to shift. Let's choose key equals 3 for this example. This means every letter in attack moves forward by 3 positions in the alphabet. For instance, A becomes D, B becomes E, and so on. Without the key, the code is difficult to crack, but with it, decryption is simple. The Caesar cipher uses only the English alphabet. When shifting a letter goes past Z, it wraps around to A, like a circular loop. This is where modulo comes into play, ensuring the shift stays within the alphabet's bounds. Since the English alphabet has 26 letters, we use mod 26. By combining our plaintext key and modulo math, we generate ciphertext. The ciphertext is unreadable version of your message. Without the exact key, impossible to crack. Before we can encrypt with the Caesar cipher, we need to give each letter a number value. In programming and cryptography, we often start counting from 0 instead of 1. In the English alphabet, the first letter is A, so its index value will be 0. The second letter is B, so its index value will be 1, and continue all the way to Z, which is 25. This method is called zero-based indexing. Let's encrypt the plaintext secret into ciphertext. First, we'll find each letter's position using our alphabet index. S is at position 18. E is at 4. C is at 2. R is at 17. E again at 4. And T at 19. Now we'll apply our shift key of 5 to each number. Let's do the calculations. After performing the calculation, we get the result 23. Now, checking our alphabet index table, we see that position 23 represents the letter X. Repeat this process for the rest of the letters. After completing all steps, our final encrypted output is X, J, H, W, J, Y. It is now ready to be sent securely to another person. To recover the original message, we apply decryption formula. Decryption formula is derived by isolating P in the encryption equation and subtracting the key. Just like encryption, decryption follows the same steps. Simply apply them. Remember, to decrypt the message, we need the same key that was used for encryption. Now we can see we have successfully decrypted our message. While the Caesar cipher was revolutionary for its time, modern cryptography exposes its critical flaw. In English, it has only 25 possible keys, making it highly vulnerable to brute force attacks. Thanks for watching. Don't forget to like, subscribe, and I will see you in the next one.